Then let's start off with the microservices, and then we will follow up with the cartridges. So the first topic is going to be JChem microservice introduction, and here Balázs Zajcsák Balú will highlight a little bit of a brief summary of this new microservice architecture and what are the differences compared to the JChem Web Service Classic. And later on, he will also provide some nice examples how to migrate, for example, your database from JChem Web Services Classic to microservice architecture. And Balú, the stage is yours, and I'm myself.
Hello, everyone. So we are now talking about some small things that might interest you in a later talk. We will have a webinar session after this short presentation. So if you want any details, please ask for them. First of all, let's talk about the architecture that we provide with JChem microservices. When we were designing this tool, we were expecting you to run in a cloud environment because it was a frequent request, and everything showed that world is going this way, which means that you want to scale up and down your instances, and you don't know how many instances you have and which machine it is running on, or things like that. And also that you want to share your workload and your calculations with many machines. Okay, so how we provide all of this. First of all, we have 3 special modules which are exactly for this cloud functionality. These are the config server that centralizes the configuration to one point, and you don't have to visit every machine one by one to apply some settings. We have a discovery server, so all these computers can work together, and the gateway, which should be the only available service for outside of your trusted zone. And of course, in the middle, we have a lot of chemical intelligence that can be on many machines and can change dynamically as you require. These modules that we have are the calculations module, which is for various chemical calculations and could be really interested to scale up on large workloads. We have the DB module for persistence and searches, IO for chemical format conversions. We have 2 separate structure generation, logic, Marcus enumeration, and reactor or structure generation by reactions. We also have the structure checker and fixer to let you ensure your chemical compliance in your future applications. And we provide structure manipulation, which is the collector of all the interesting APIs from our rich Java API that most of you know and love, but they are not available in other languages, so this could be an endpoint for that. And we are using Swagger to document our API, which is convenient because it's also a live tool that you can try, you can use to try it out. And also Swagger has a code generator that can generate many clients if you want to reach our application from another language. And it's a very short demo on how to do that. Just simply copy this resource, which is on the top of every documentation page. This editor.swagger.io is an online tool where you just paste the URL and then generate a client in the language that you like. In this example, I have chosen Python, and it took 5 or 8 seconds to generate it. And you will see soon that it has downloaded to my computer. So now for some words for the administrators. We have several packages of the same application. We have a UI installer for the the maximum convenience where you can just click through a next, okay, installer and select which components you want to install and whatnot. We have a fully automated installer for system administrators, and we also provide these in deb and RPM repositories if you want to automatically update your system with the latest artifacts of microservices. And we have full manual installers, which are simply zipped versions of the applications, because sometimes we face users who need such packages because they don't have other rights on the servers that they maintain. And also, if you are using some orchestrator system like Kubernetes or Docker Swarm, then first of all, we have Docker containers that you can use. We also have guides how to build your own Docker container if you are interested in it. And you can find all of these on our GitHub page. And if you are using an orchestrator system, then you might need another setup than the bare metal cloud setup I have talked earlier. You might not need all the cloud orchestration things like the discovery service or the config service or the gateway. And we can help in such situations how to set up something like that. But you can also go with these setups. Our documentation and examples shows this. And one more very important thing, we are completely supporting all well-known cloud providers. We don't have anything against any of them. You can run on EC2, on Cloud, Google Cloud, on Azure. You can use Kubernetes on any of these providers, or Docker Swarm, or Elastic Container Registry, whatever. So there are some important changes that worth to mention in microservices compared to Web Services Classic. And these are that in the DB module, you have a separate step to create your tables, and not creating your tables with your first upload. And now the standardizer config goes into your molecule type, which was introduced with Postgres cartridge, and I think will be also mentioned during the upcoming talk. And this molecule type is set when you create your table, and this will set a lot of things for your searches as well. And the chemical data uses relevance ordering now. When you get back your results, it will be with the most relevant at the beginning, so you don't have to get all the results to find the one that your user was looking for. You can just get the top 10, and this will be the top 10 most matching molecules. We also provide this fingerprint bit distance between your query and the results. So if you are querying more resources, more data sets, then you can order the results to provide them in the most relevant at the top when you are presenting the merged results. And we also have included a convenient picture generation endpoint for the database molecules, because it made a lot of hard moments for our previous users. And okay, let's talk about the calculations module. This module, the main selling point of this module is that it is much closer to our Java API, which is also means the logic and the capabilities. We have a better functionality coverage, and we are working in a very fast feedback loop with our users. If you miss some calculation or you need some different result set, then please contact us, and we will try to provide a solution as soon as possible. We have an IO module, which is also closer matching for our Java API. And if you know our API well, then you will find it very convenient. And it is also important that it is finally not relying on any persistent storage just to convert from an SDF file to a slice. We have structure manipulation, as I have mentioned before, which is all the previously not provided Java APIs. It is, and if you miss something or you need something, please contact us and test our fast feedback. We have the reactor module. This module is a full functionality coverage over our UI tool or console tool. And we also have automatical reactant list assigning functionality, which was requested many times before. We have the structure checker fixer module, which is which provides full API coverage as well. It follows the same logic as the Java API. You can save presets for your frequently run checkers and fixer compositions. You can run batch execution and you can filter the results if you want to. Okay, and now just a short example of how to migrate your existing JChem Web Services Classic database to JChem Microservices. In this example, you will see how I create a table in JChem Web Services, download all the data with JChem Manager and convert it to the format of JChem Microservices and upload it to JChem Microservices. So if we start this, you can see this is the creation of the table with these two simple molecules. And now start the JChem Manager, which is a standard tool for years in JChem package. Just connect to the database and export your table. During export, we have to select the table and what fields we want to export and the name of the file where we want to save it. These are the fields that we have selected to export. Okay. Both molecules exported. This is the content of the file. We have this migration tool on our GitHub repository. You can download it. It's fully open source. There is a documentation in a README file that you can follow how to use it. And first of all, you will have to set your authentication properties for accessing our artifacts. You can do it by copying it from the Gradle panel on your on the Chemaxon site after you have logged in. Just copy the exported molecule file into the input folder and start the process. It will compile and start up. It takes a couple of seconds. Now you can see that it has started, finished already with the two molecules. Copy the exported JSON file to the DB's export folder. And this will be the folder where you will be also able to import it. Just create the table, use the correct molecule type with the correct standardizer settings to get the same result as you would expect in JChem Web Services Classic, and then import the molecule. Now we just verify it with a simple query, and as you can see, we have both molecules and they are in relevance order. The smaller molecule is closer to the simple carbon atom that we have used in the search than the larger molecule. And basically that's all. So prepare your questions for the further discussions, but before that, please listen for the cartridges and what Tamás has to share with you. Thank you very much.
Thank you very much, Balu. We can go on with the cartridges. So Tamás Varga Tomi will present us a little summary about the new cartridges and then a migration from the JChem Oracle cartridge to the Postgres cartridge and JChem Oracle cartridge to the Choral, which is also an Oracle-based cartridge.
Okay, so I will talk about the migration process from the old cartridge from the Oracle cartridge to the Postgres cartridge or Choral, because many of you are using the Oracle cartridge, but you are afraid to migrate your programs and data because it's usually a very difficult thing to migrate, and and that's why we made this small presentation and demo how to do that to help you. This is the agenda, so I will talk about the reasons, the strategy, the migration strategies that you can have, the migration steps, and in the end I will show a demo migration. The reasons to migrate, yeah, usually you want to migrate to get the new features, especially the hit as you draw feature, which you could see many times now. The performance of the new cartridges are better. They handle huge databases better, or simply just getting the latest developments of Chemexon are good reasons to migrate. And in case of JPC, it is the Postgres is an advantage that it is cheaper, and usually for big companies there are some company-wide decisions which database people should use, and Oracle is not that popular nowadays as it was before because of the pricing, I think, and there are some companies that need to move to Postgres for a company decision, so it's not in people's hand, they have to move. So JPC has high availability, Choral has this, is working on RDS, on Amazon RDS, so these are also very important points for people to choose the new products. About migration strategy, it is important for large companies, for large systems, large ecosystems to have some kind of strategy. And if you want to migrate to JPC from JOC, it is more like migrating from Oracle to Postgres. And there are two strategies which are very different, and you have to choose from them. The first is, both has pros and cons. So the first is just moving everything at once to Postgres from Oracle. That's I think it's very difficult if you have many client systems. If you have only a few, it may be possible. But as soon as you did it, you can turn off your old setup and you are good to go. So that's the pro. Or you can do it step by step. So just install the new Postgres and JPC, move your clients just step by step as soon as they are finished with the migration. But the difficult thing is that you have to keep the old setup, the Oracle setup live until all of the client systems have finished the migration, and you also need to keep your data synchronized, which is not easy if you are talking about two different databases on two different systems. So both has pros and cons. We don't want to decide which is the better. It really depends on your system. I just advise thinking about it before starting some kind of migration to what is the best strategy to do that. And for Choral, if you want to change from JOC to Choral, you don't have that problem at all because no synchronization needed. You just install Choral for the same columns as JOC and you are good to go. And you can move your subsystems step by step without any problems. So it's an easier thing if you do that. And about migration, there are some migration steps that are non-cartridge related, and there are some that are cartridge specific. And first, about non-cartridge related, that means if you go to JPC, then you are moving, again, I have to highlight that you are moving from Oracle to PostgreSQL, and that's the difficult point. you can do it manually. That means all your code has to be converted to the PostgreSQL language. And if you do it manually, it may be very difficult. If you have a very large system. With a small system, it's probably not that difficult. So if you have a very large system, maybe Enterprise DB is the best solution, which allows you to have a Postgres engine, but with Oracle compatibility, the PL/SQL compatibility. So all the code that you had, they promise that they will work with the new one, with the Postgres as well. And we also provide releases for EDB on request. If you move from JOC to Choral, then there are of course no non-cartridge related migration steps, because we are staying on Oracle. And now comes our part, the cartridge specific steps first from JOC to JPC. And I can tell you that it is not difficult, the data migration itself, because you just you export your data from Oracle, import it to Postgres, you install JPC, and the only step that that might be difficult, but not that difficult, is converting the column type from text that that was CLOB or BLOB in Oracle to a molecule type of column in Postgres. It's not difficult, but that's the only step that I would call specific for JPC. I will show that it's really not difficult. Then you are able to create indexes. So that's the data migration part. If you go from JOC to Choral, you can simply install Choral, create indexes with Choral on the same columns as you did it with JOC without any problems, and you are ready to go with both cartridges working. I will show a small demo for that as well, so you will see that later. So if you are finished with migrating the data, you have to migrate your code too. And when you do that, I think the most difficult part is finding all those codes, or all those calls for cartridge calls in your code. And then you have to change it. And it is not straightforward, but not that difficult as well. Although we don't have automatic conversion tool, I think it would be very difficult to write one. But we have a guide, a documentation. I will show the references later. What I want to highlight is that the core chemistry engine is the same, except Totemer handling, which was improved. So if you get differences, they will be systematic, not like changing software between vendors. So the core engine is the same. That's important. The other point that I have to highlight, that you had index and search options before probably, and you don't have that in the new cartridges. It was redesigned, and we have query transformations and molecule types or subtypes. I will show some examples how they have to be converted. And the typical problem that people first see, that they don't know that the default query format has changed and the results are different, but it is very easy to solve. But first it would raise some eyebrows why it didn't work. I have examples for that as well. And there are still some missing functionalities like similarity descriptors and some others that may be implemented later in the future or on request. And you won't be alone with the migration. We can also help, but we have a very good guide, a very detailed guide to how to migrate from JOC to JPC, and we also have comparisons if you see different results for the cartridges. There are some very tiny details that which could cause some small differences in the results. So I will go to the demo now. I will first start with JOC and Choral. So here I have a JOC installed, and I simply installed Choral for the same user without any specific steps. So it's just a simple install. You see that the JC compare from JOC works. The sample search or some kind of search works with Choral as well. I set up a table with 1,000 rows. I will show how they look like. They have an ID, a structure, and a mole weight column. So a very simple table. I have a standardization file. I try to show it now. I think you can see that there is some kind of standardization. It's not that important what it is specifically. And I drop the old index and I create a JOC index. So probably this is what most of you have. Usually you turn on halt on error, never fail or something like that, just to get rid of the errors. And I set up this standardization configuration file. So this is some kind of typical index creation parameters. And now I want to do it for the Choral as well. I prepared, so I said that the search options and index options will be, some of them will go to the type file. So I will show a type file for you. I prepared UGM demo, like user group meeting demo, and UGM demo tau for the Totemer type, and they are stored on the JChem servers. And yes, this is the machine. I hope you can see this screen as well. I'm not sure. Can you?
We can see the screen.
Okay, so I had a UGM demo type file. It has a type ID. Totemer is turned off. There is some settings for stereo assumption, and we have a standardizer file which I will show you, and basically that's it, some fingerprint configurations, but that's not important now. And I want to show that XML file with the standardization. I don't know how well you can see it, but it's the same that I showed you in the database. So the same aromatization and transformations are here as well. So I didn't have to change anything, just put that standardization into the type files. And yeah, I wanted to show the Totemer file as well. Yes, the only difference is that the totemerization is set to generic. So I have two types now. One is a normal, let's say normal, and with generic totemerization, and the same standardization setup. I wasn't talking about halt on error. That's because halt on error is not necessary, because the newest releases work with the same settings as halt on error, never fail, or something like that. So you won't get errors for missing molecules. You have other tools, other functions to find them if you want to. So now I'm ready to create a Choral index because I have a type now on the structure column, and the index type is UGM demo underscore index type. So it's not the Totemer type, but the simple type that I use now. And it is on the same structure column as I have with the JOC index. So now I have the same column index, and I will search first with a Sims2 structure or with JC compare, so with JOC. And this is the Choral statement to do the same thing. No, not much difference, only the third parameter have to be written differently, but it's an easy transformation. And as you see, 30 hits for the first one, 30 hits for the second one. So it's basically, you're basically getting the same results. I collected some more difficult queries with some options. Here I turned on ignore tetrahedral stereo parameter, for example. So I turned it to yes. I have 13 hits here, and here this is the place for the query transformation. So this time it's not a search option, so it's not an option of the search, but it's a transformation of the query itself. It is not, the difference is not that clear for Choral, but you will see at JPC that the syntax is more different. Anyway, you get the same results if you transform the options to these query parameters. I've got, I was talking about the difference between smiles and smarts, and I tried the same query or with a different query structure, and I've got 2 hits here, and I did it with Choral as well, and I've got 30 hits. So this was the point where something, you could think that something is wrong, and yes, something is wrong, that the default query type or input type is smart in JOC. So this is this is treated as smarts, but in the new cartridge it is treated as smiles. So you have to transform to smarts first as the second query to get the same results, and that's very simply just put the word smarts in brackets behind the query, and now you get the 2 hits, so you get the same hits as in JOC. So it is not difficult, but first you can do this mistake, but you can correct it easily. So the second example, a simple example again, that the Totemer search works differently. I mean that in JOC you had this search parameter Totemer Search yes, for example. Here, without the Totemer Search parameter, you don't get hits. With the second query, with the Totemer Search turned on, you've got the hit for a duplicate search, and for that I created the Totemer index in Choral as well. You see the index type is UGM demo toe on the same column again. That's important. So I could add another index as well. And now if you do a duplicate search with the original type, you don't get hits. But if you use the UGM demo toe search, so the U type, the Totemer type, you get the hit. So I think that's not difficult change these queries. Of course, if you have more complex queries, it might get a bit more difficult. And now, so this was the part that the transformation of queries and structures from JOC to Choral. But what about JPC? So if you want to convert to JPC, move from JOC to JPC, first you need to transfer the data, and I will export the data for this table, for this UGM table first, UGM demo table first. There are many ways to do that. I use this SQL developer tool, but almost all tools can do some export. I selected the table, I hit export, I don't need the DLS, and I exported it to CSV. We have this also in our documentation. I hit next, and finish. And it's a bit slow because my computer is very far away from the server. But as you can see, it exports the structures. But to be honest, I cheated a bit, and I did it before, just to not to wait for that. And I uploaded it to the server where the JPC was installed. And yes, this is the file. So this is ID, structure, mole weight, and the contents of the table. So it's a very simple file with separated values. And now I will go to my JPC or my Postgres database. I installed the same type files as for Choral because they are the same. The same can be used. Now I drop the table and I created with the same structure, only that this structure column that was a CLOB in Oracle is a molecule type with a UGM demo subtype, so that type file and the mole weight. I created the table, and there is a simple copy command to import that file from a CSV. You can give the file name, and it is already imported, so it wasn't difficult as well. I've got the 1,000 rows here, and you can see that the data is really here with the structure as well. And I'm already creating the index, and I'm ready to go. But if you use other tool, I will simulate that, and then you don't have this. You don't create the table as structure UGM demo, but you maybe create it as text, as structured text. I've got the same table, so this is probably your starting data, and you want to create an index. You won't be able to do that. It says that that no operator is found because text can't be indexed in JPC. You have to convert the column, but this means 5 steps only. So I renamed the original column, add the new one with the UGM demo type. I copy the content of the text data to the structure column, commit it, and drop the original column. And I've got the same table now with the same structure. So 5 steps, and you are good to go again. And now the indexing will work. So the index is ready. So that's the data migration. So I think data migration is really simple. And now I want to show almost the same as for Choral, that for a simple query, I left the original query from JOC here. that had, if you remember that it had 30 hits. The this is the query with the JPC and the Postgres syntax. You've got 30 hits as well. This is the operator of substructure search. Yeah, you need to do the translation or transformation that we were speaking before. The syntax is different. When you did a query transform, here it is a function, so you transform really the query with the transformation. This ignored tetrahedral stereo, and you get the same hits as you did with the search parameter before. You have to be careful again with the smice and smart, because if you don't do it, you will use the queries as smice while you maybe used it as smarts before. And the transformation is by this molecule function, where the first parameter is your query, the second is smarts, so it's not difficult as well. And you've got the same hits as with JOC. The totemerization is a bit different than in Choral. You need to add a new column because the molecule has a type, which is JChem demo type, and the column can have only one type. So you need to add a new column and copy the structures to the new column. And now you can have the duplicate search that you wanted on the original column. Then you don't get hits because Totemer Search is off, or you can use the U one or the Totemer column, and you get one. So this is a bit different than in Choral, but I think you can handle that. If you don't want two types, usually you want one type of search, then you need only one column to do that. So that's I think that's the preferable way. So that's all that I wanted to show you. Again, you can see the references here that can guide you in the process, or the team also can help you if you are stuck with something. And
thanks a lot.
Yeah, I wanted only to tell that we are open to discussions now and later as well. So if you have questions or remarks, then please tell us.
Thanks a lot for your presentation. I believe this was done as well. Please find us on LinkedIn or email if you have questions. Thank you for your attention and see you soon. Take care. Goodbye.